Hi everyone. I'm Peibo. I'm a PhD student here at UNSW, and I'm supervised by Professor Flora Salim, Professor Maarten, and Professor Yang. And today, I want to introduce our work large language model to for our next point of interest recommendation. So, uh, have you ever found yourself just traveling or simply walking randomly in the city? And would you wish for some apps, maybe Google Maps, to give you some suggestion, like any locations that might interest you? So, and this is where the need for next POI recommendation comes into play. So POI data, which essentially includes checking records, and it contains location information, user checking times, and sometimes user reviews. And this data may be straightforward to human, but can large language model understand it, like the semantics of this data? And we tested with ChatGPT by input POI categories and asking it to list category names that have intersections by their context. So what you can see here, for each table, the right column is the row data by the dataset, and the left side is the generated category by ChatGPT. So as a result, ChatGPT was able to summarize all these categories by their context. And this text really requires the model to have some prior knowledge and understanding of the semantics of these categories. And as I just mentioned, POI data can be heterogeneous. So traditionally, models will have different branches to process different types of data and transform them into embeddings. But this process can lead to a loss of semantics. For example, the POI categories you just see are first transformed into IDs, and at this point, you can no longer discern the type of POI by simply looking at the category, as it is now just an ID. So, and the design of these approaches can often be overly complex, and they really rely solely on statistics, and they don't have prior knowledge. But if we can utilize LLMs, we can simply describe the data in natural language and keep the data as it is. Also the overall methodology can be simplified, not to mention they have understanding of semantics. And in our work, we introduced trajectory prompting to retain most of the semantics of POI data and feed them into LLMs. Specifically, for each checking record in a trajectory, we describe them in natural language, and we combine these checking records into trajectories. Our prompt consists of 4 blocks, which can be divided into 2 parts: question and answers. The questions are the user input to the LLMs, and the answers are the expected output from the LLM. The first 3 blocks construct the question, and the last block provides the answer. The first block is the current trajectory block, which contains the current trajectory without the checking records, which we want to predict. The second block is the historical trajectory block, designed combined with the first key query similarity to address the cold start problem, because these POI data often have the cold start problem where users may not have sufficient data. Therefore, we need to borrow similar data from other users. And we designed this key query similarity to select trajectories that are closer to the current trajectory we want to predict. We include this trajectory into the in the historical trajectory block. We also have the instruction and target block, where we guide the model on what to focus on. The target block contains the timestamp, user ID, and POI ID for the checking record to be predicted, which also serves as the ground truth for fine-tuning and evaluation. And the datasets we used are through real-world checking data from New York City, Tokyo, and California. We were able to surpass all previous models on all three datasets by a large margin. And we also find some interesting facts. You can fine-tune this model on only one of the datasets, and it can perform very competitively on the other two datasets, which demonstrates strong generalization ability of the LLM to unseen data. And one of our ongoing project is to explore whether we can capture user behavior on a global scale. And the data we use covers multiple regions, and the users are not confined to just one city or one region. They might travel across the world or even countries. And they are also come from various backgrounds. And this makes the use cases more aligned with real-world scenarios. But of course, in real-world scenarios, there are many more aspects to investigate. For example, can we make some personalized recommendations? Can we provide explanations to users about why certain locations are suggested? And our posters are just outside, so if you're interested, please do come and talk to us for some further discussion. You can also contact us by the email. Thank you.